Hey everyone, thanks for joining us. So today we're going to give a quick overview of the brewlytics platform. We've got a lot to talk about with brewlytics. We're going to have about a dozen different videos where we detail all of the features and the capabilities of brewlytics, how to use them, and all those sorts of things. But today we're going to start with a very high level overview of the tool. I'll start to say that we call brewlytics a self-service data analytics platform. And basically what that means is that we, as developers of this tool, we provide a platform that allows you as the end user to take all of the analytic functions, all of the things that you do every day, such as querying a database, performing calculation, filtering data down, all of the various steps that you take your data, bring it all together, perform your analysis, and turn that into an end product for either you or a decision maker or whomever needs to see the data. We provide that platform where you can automate these things. So instead of going through and doing that same process day after day after day, you can come into brewlytics, you can model that workflow, and then you can come in there the next day and run it, or you can set it up on a schedule to run every couple hours or every day or however you need. Okay, so when you're capturing these workflows, one of the interesting things is that that captured workflow is now something that you can share with other people. So I can build a workflow, I can share it with another user, and then they can come in, they can edit it, they can run it, they can create their own copy of it and branch it to do their own thing. So collaboration is really a key capability to this tool. When you're building these workflows, the idea is that now you can take that workflow and build off of it in the future. So that tradecraft that you're codifying into this workflow is now usable by everybody else within your organization. And really, when we talk about the tedious processes, we're talking about everything that you do. So, like I said earlier, if you're querying databases, if you're filtering data down from all of these disparate data sets that you have across your organization, when you're applying calculations, whether that's simple math, arithmetic against the data, for example, you're aggregating columns of data and summing it or averaging it or whatever, even down to more complex calculations like geospatial calculations. For example, if you have polygons on the map and you have points on the map and you want to perform geospatial joins of that data, or you want to calculate how many points fall on this polygon, it could be temporal calculations. So you could be doing things like, I want to figure out all of the points that fell within this bucket of time, this day or these 6 hours or something like that. All those different calculations that you might do in tools like Excel or Tableau or whatever tool that you're using. We provide those end user functions. And one of the ways that we like to describe these functions as analytic Lego blocks. So we give you a bucket of analytic Lego blocks and we allow you to stitch these things together however you want to build whatever you want. And that's really the power and the capability of this tool. We work very well with being able to bring disparate data sets together. So blending and joining different data sets together within the environment, within the brewlytics environment, when you bring data into it, we have what's called the common vocabulary. And basically what this means is that when we're bringing in all of these disparate data sets, we're performing some normalization to the different data types across all of these disparate data sets, so that when you're dealing with things like time across different data sets, they're all in the same format. So you as the end user don't have to waste your time dealing with those things. You can just jump right into the analysis. We also work well with others. So you can output your data from brewlytics to virtually any type of third-party tool. If you want your data to go into Excel is an easy one. If you want to have your data going to Google Earth or Esri shapefile or GeoJSON or XML or to Tableau or whatever, we have functionals that allow you to take that data and convert it into those formats. So we work very well with other tools. Every workflow that you build within brewlytics also becomes a REST API. So for the tech folks that are listening in, that means that you can take a workflow, you can build a data workflow within brewlytics, and then you can hook it up through your API to another tool, and you can call that workflow, get the results, and do something else with it. So there's a lot of different things to unpack there. We'll talk a little bit about how it works here, and then we'll jump into the tool and we'll show you a real life example of stitching these functionals together to build a workflow. So as I mentioned earlier, a functional is just a single function that you perform in your day-to-day work. It could be querying a database, it could be performing calculation. Maybe you have a calculated value that then goes into a follow-on query. You need to convert this data, you need to manipulate the data, and then ultimately you're going to output it in some way, shape, or form, whether that's to a spreadsheet or to a different third-party tool where you want to visualize and analyze the data. We have all of those functionals so that you can stitch them together however you want to kind of make whatever you want. And we take those functionals, we stitch them together, and we build what's called a workflow. We'll also see it called a model. So workflow and model are kind of interchangeable when we're talking about them in Brewlytics. And with that information, I know there was a lot there, but we're just going to jump into the tool. I'm going to show you around a little bit, and we'll build a very simple workflow. Okay, so from this page, from brewlytics.com, the first thing that you can do to log in is you can actually request a demo account, a trial account. And so if you click the login button up here in the top right, that will take you to our demonstration instance of Brewlytics. There's a button down here to sign up for an account. So if you want to sign up and play around on here, do that. We'll approve your account. We might reach out to you and kind of see what see if you need help with anything or see what you're working on. But after that, once you get your account approved, you can go in and log in. So you'll just put your username, password here, hit log in. And from there, there's two main areas within Brewlytics: Discover and Build. Discover is more for finding things that have already been built. But since today we're talking about how to build these workflows, and the build environment is really the main portion of the application that you're going to be working in as a builder. So I'm going to just launch that. When you launch the build button, you see a couple different areas: new workflow, new app. There's the trending workflows, recent workflows that you worked on, and then any favorites that you might have put into your favorites category. You can also search for a workflow. So if you have a workflow that you've been working on, you can type it in there, pull it up, go into it, and continue working on it. What I'm going to do is just start a new workflow, and I'm going to show the simplest example to start out with. We're going to create a workflow that simply defines a string of text. And so I just search for that workflow. I pull one of these functionals in. And remember, these functionals are analytic functions, right? So they do things that you would normally do in a day-to-day setting. They might do things like filtering data, querying data from a database, converting a data from, let's say, a table into a list of values, or a table into a GeoJSON file, or any of those different types of conversions that you might want to do. And those functionals can either be searched for, like I did earlier, or you can go through the list of functionals and you can kind of drill down into these various categories. So for example, with arithmetic, if you want to take a couple decimals and add them together or multiply them together, we have functionals that would let you do that. I'm going to delete that for now, and we're going to start with just doing the simplest example that we can. We're going to do a hello world example where we're simply going into this functional, we're providing it the input of hello world, and since all this functional does is define a string, when I run this, the output is going to be that same string that we defined. So again, simplest functional that we have in our repertoire. It simply just defines a string. Now I'm going to show how we take something like that and turn it into a workflow, build it out, throw other functionals into the mix, and build something. So what I'm going to do is just copy and paste this define string functional, and instead of saying hello world, let's instead just say hello. And in this next one down here, I'm going to go and change this input to world. And so now we have two defined strings. And if I were to run this one, you can see over here on the right says hello. And then this one on the right says world. Okay, so we have these two outputs. Everything on the left of a functional are the inputs to that functional. A functional may have one or more inputs. It could possibly have no inputs. And then the outputs, it's going to have one or more outputs. In the same way, it could have no outputs, but typically a functional has one, maybe two, maybe three outputs. Okay, so now if we want to use those outputs in our workflow, we can take these outputs and connect them to other things that we've got going on in our workflow. So the next step would be to figure out what we want to do with this data. Well, what if I want to combine these two strings together? So instead of saying hello world in one string, I've got these two defined strings, and I want to create a workflow where we bring them together. I'm going to find a functional to combine these strings, and I know it's called concatenate strings or combine strings. And so this functional has an input for a list of strings, and then it also has an input for a separator. This would be the separator between these two strings. So for example, if you wanted a space in between the strings, or you wanted a comma or something like that, you would put that in the separator, and then for every value it took, it would throw in that separator value. So I'm going to hook up the string list to our first defined string and then our second defined string. And we have this automatic routing. So as you move the functional around, it will try to find the best path. And depending on if you have the inputs open, the path will change. So I'm going to first just run this, and we won't put any separator value in, just so we can see what that would look like. And you can see at the bottom here, it says hello world. Now, if I want to put a separator in there, I can go back to that input, and let's just say this one is going to be space. So now when I run this, it's going to say hello world with a space in between. Okay, so again, a very simple example. In practice, you probably want to be doing something like this, but just to show you how things connect together within this environment, we can also create variables attached to these. So a variable is kind of a special input that allows you as the end user to change this thing as you're running this workflow. So if I were to build this workflow and share it with other people, somebody else would come in and they would see that this is a variable, and they might want to change this to say, hello brewlytics or something like that. And then if they run this, obviously it's going to take that new variable and create that new output. We also have this notion of outputs. And outputs are important. Variables and outputs are important in that anything that you define as a variable and an output has special meaning. One of the special meanings of these two elements is that the variables and the outputs will be exposed via our REST API. So if you're integrating Brewlytics and integrating a Brewlytics model with another application, those variables and those outputs will be available through that REST API. Additionally, if you use this workflow inside another workflow, these inputs and outputs will pop out as that sub workflow or that sub model. And I'll show what that means here in a second. So we're just going to call this test model 1. And so now I've saved it. I can share it with other people. I can say, hey, I want everyone to be a guest. And let's put Ken Pratt as a collaborator. And then now that we've done that, we can open up a new model. And if I wanted to use this model or workflow within this workflow, I could come in and search for that. Test model 1, we called it. So let me search for that. It's down here. Test model 1. That has the input string and the output string. So instead of seeing all those various inputs and outputs that we have throughout this workflow, now we're only seeing this one and this one. So we're kind of operating with it in kind of a black box state where it's got all of those functions inside of it. But for us, we just see our input that we defined. So let's change this back to world. And then we have this output. We'll go ahead and run it. And we get that as the end result. Okay, so now that we've shown a very simple example, I'll show a more of a real life example working with data. So maybe we have some data on earthquake data within the Brewlytics environment, and within the demo environment, there's lots of different data sets that you can play around with. If you type in something like query, you'll see all of these different APIs that we've connected to. We've got things like crime data, geocoding data, we've got housing data, weather data, aircraft data on different flights flying around. We've got ship AIS data. We've got spacecraft data, social media data, Yelp data, lots of different things that you can come in here and play around with. But we're going to search for earthquakes. And I'm going to pull this functional in. So now this functional has various inputs. It has an area of interest, or an AOI. That's a geographic constraint. So it says, draw a box somewhere on the map put that in there, and then we're going to query that data set for that area as well as a date range. And then there's some other variables that we can fill out. Those variables, like the AOI and the date range, I can either fill them out by right clicking and editing the value. So if I wanted to pop up the map, I could do it that way. Or I could click on the functional and it's going to be over here on the right as well, all of the inputs. So let's just fill out this area of interest. We'll go over to the West Coast. We'll draw a box. So I submit that. So notice when I put that in, I'm getting a green checkbox around this input. And then when I go into this date range input, and let's put in the last 30 days, how about? I'll get a green checkbox around that input as well. So let's go ahead and run this. So what's happening when I run this is going out to the USGS Earthquake API. It's querying that data set and then bringing the data back into brewlytics. You can see the output of this functional is a table. And so that table, if I hover over it, I can do things like view the results. I can download the resource. So if I wanted to download it as a CSV, I could open it up in Excel that way. I could see some info from the table if I wanted to. We've got all the column headers. We've got the rows in here, the amount of columns in there. Let's just start by downloading it. We can either view this data in a couple different ways. We can either pull it up in this data table, which will just give us a quick preview of the data, and we can search through that and do all those sorts of things, sort it. If you just need to see the data quickly, this is probably the best bet for you. But if you wanted to download it and pull it up in something like Excel, we can take a look at that data. And so that data now, we can see basically one row is one earthquake, and we have all of these different variables, like the magnitude of the earthquake, the location, the time. We have different things like latitude and longitude, so we have geospatial information, and you can see all these brackets in the column headers. So remember, I was talking about common vocabulary types. We're going to have a video separately on that, but one of the things that is important to understand is that when the data comes into brewlytics, it gets a common vocabulary type, and so that allows us to do things like create these point columns, where if you're dealing with any geospatial information and it's a latitude and longitude, you're going to see a point column. And that allows you as an end user to be able to work with this data geospatially without having to worry about converting into a different coordinate system, or from MGRS into decimal degrees, or even DMS into decimal degrees. All those things are kind of taken care of for you, so you don't have to waste your time with that. Okay, so the next thing that we need to decide as somebody building one of these workflows is, what do we want to do? Maybe we want to filter down some of this data. Maybe the magnitude is a key variable that we want to filter down. So we could throw in another functional to be able to do that right within our workflow. I'm going to throw in a filter functional. And so you can see there's a whole bunch of different filters that we've got. One of the things that we'll throw in here is just this filter table rows. And so now this functional has its own set of inputs. You can see some of them are red. This is signifying that this input is a required input and we need to provide some sort of value into it, or else if I were to run this workflow, we'd get a complaint. So you can see a validation error. And if I hover over this, up at the top, it says missing required input, and so it's not even going to try to run it. So we have to satisfy this. We're going to put in the table value here. We're going to put in the column, and that column name was magnitude. And let's say we, actually, let's change this, since we threw in the filter table rows. This is actually more for filtering categorical variables or text variables. So let's find a categorical variable that we might want to filter on. Maybe this NC value. It looks like some are NC, NN. Maybe we want to filter things that were magnitude type, MD or ML. Maybe we wanted to change the type here. I think everything's probably, okay, so some are actually quarry blasts and some are earthquakes. So maybe that's an interesting thing we want to filter down on. We only want values that are quarry blasts for whatever reason. So let's change this to, I think it was called type. I'm just going to double check that. Yeah, so it's called type up here. So we're going to filter type, and we're going to filter by Corey Blast. And now let's go ahead and run this workflow. So you can see now it's running that functional, getting the USGS data, and it's taking that table, throwing it into this filter function. And if I open this up now, I only have 5 entries. So now these are all Corey blasts. And then maybe we want to filter down even more. Maybe we only want things with a magnitude greater than 1, for example. Let's go back into our workflow and throw in a different filter table. So instead of filtering the table rows, we're actually going to filter the table rows by number range. And in the same way, that has a required input of a table. So I hook that up. It has a column name that's a required input. So we'll put in magnitude, and maybe we can set the minimum or the maximum. Let's say the minimum that we want is 1. So now let's go ahead and run this one. If I pop this up, now we have things that are only higher than 1. So now we've created a repeatable workflow where it's always going to query the USGS data. In this case, we've hard-coded these values in, so the area of interest and the date range are going to remain the same. The data is going to go in and get filtered by the column value for Corey blasts against the type column, and then it's going to filter the magnitude. From here, if we wanted to do something like create a variable so that this area of interest and date range are now something that users could change when they come in here, we can do that. Maybe we want to change back to, I don't know, let's go back to October 1st, and we'll query to January 31st. So now if I run this, it should get a little bit more data, one would think. And so if we open this data up, we can see 22 entries. Okay, so now maybe you want to take this data and do something with it. Maybe you want to create an Excel file with it. That would be really easy. You just throw in something like this table to Excel. We hook that up. Just like we can bring in virtually any type of data, we can also push out virtually any type of data. So if I want to create an Excel file, I could do that. If I want to create a Google Earth file, a KML file, for example, I can throw that in here, and we can say, features to KML. This functional has a lot of different inputs. If you've ever worked with Google Earth, you can change all the stylings and things like that for the polygons, the points, all that information. I'm going to hook that up, and we're going to leave everything blank here, so it's just going to be a very vanilla Google Earth file. And let's go ahead and run this. I'm going to download it, and if we wanted to just see the dots on the map, we can see those points here. And so these are all of our earthquake hits. Okay, so now maybe we want to do something like, I want to take this data and I want to join this with other data sets. That's really one of the big value propositions of using a tool like brewlytics. We can bring in disparate data sets and we can work with them in a single environment. So we've got this US Census Boundary functional. And I think, yep, so it's called Query US Census Boundaries. This functional now has an input box, right? So this box and this box, they're the same common vocabulary type. And what that means is that even though these are two different databases, we can take the same area of interest and we can hook it up to this Query US Census Boundaries. So we're using that same geographic constraint that we put in on the West Coast, and we're going to send it to this US Census Boundaries query as well. And let's query for the census tracts. And so when I go and I query this now, let's just run this from the beginning. This is querying the USGS data. It's filtering it, creating those KML files. It's also at the same time querying the census boundaries data. And so when this data set returns, we'll take a look at that data and figure out what it looks like. As you're building these workflows, it's very much an iterative step-by-step process. So you're building the data, you're querying the data, you're putting in all the filters that you want, you're doing the calculations, and then you can very easily see kind of what comes next in this data set. You can add new functionals in, you can view the data, you can kind of change the way the workflow is set up. So one of the things that I like to do when queries are running is just kind of clean some things up and just make it look a little bit better. You can add annotations. So annotations can be thrown on into the workflow, and you can hook those up while that's running. So we ran a pretty big area, so we should get back several US census tracts, and in this case there's 3,000. So these census tracts, if we were to hook this up to Google Earth, you can see that these are going to be polygons that represent a geographic boundary. So I'm just going to create this Google Earth file so you can kind of see what that looks like. And so now this is chugging away, building that new KML file. I'm going to pull this up so you can see it's almost 40 megs, approaching 50 megs. So it's a big file because we've got all these different polygons. I probably shouldn't have queried such a big area with all those polygons. But as you can see, we can work with big data, and we can work with having all of these different polygons in here, creating the files. It's all very fast. If you're dealing with gigabytes of data, that's something that Google Earth and brewlytics can definitely handle. So no issues there. Just as you add more data to it, sometimes the calculations take a little bit longer. Okay, so we've got all of these different census tracts. Now, one of the things that we might want to do is figure out what point fell in what census tract. And so right now, if I were to pull up this data, you can see that these 3 points here, they fall within census tract 110200. But the only way that we're seeing that is by looking at it on a map and just seeing, okay, this one overlays with this one. The data itself isn't really joined together, right? It's just overlaid on top of one another. So one of the ways that we can actually bring the data together is to do a geospatial join. And so the first thing that I'm going to do is just make this area a little bit smaller so that we're not pulling all of that data again, just to make it a little bit faster for the video. And I'm going to grab a functional called join by geospatial features. And what we can do now is we can take our earthquake data as the base table, and we can take our census boundaries as the join table. And we can say, I want to join these 2 data sets together based on the intersection of that polygon with that point. And so what this is going to do is join the metadata, or the fields from this table, all of these different fields, into that other table that we had on the earthquake data. And so you might say, okay, I really don't care about all this other data. The only data that I care about is this name, this census tract information. So if I go back in here, I could say I only want to join in the name column. So let's do that. And we'll just run this from here. And so this performed that geospatial calculation in no time, really. Let's pull this up. And you can see we've got 22 entries. So this, again, goes back to our original earthquake data. However, if we look on the right side of this data, we're going to have a new column in here for that census tract. So we essentially just join these 2 data sets together. Why is that important? If you were going to do something like plot the information, you wanted to know what census tract has a high amount of quarry blasts, or even just quarries, active quarries within that census tract, this would be a way to bring that data together. Now, this is just an example, obviously. When you're working with brewlytics, you're going to have your own data. The first thing that we do when we start working with a new customer is figure out what data that they need, and we can either go out and get that data for you, or you can bring it into brewlytics yourself. So there's a lot of different options there. Okay, so now that we've brought these 2 data sets together, I'm going to delete some of these things. I don't need the Google Earth file. I don't need that Excel file anymore. And we've got this new data set, like we were just pulling up. Maybe I only care about some of these fields in here. So I only care about time. I only care about magnitude. Maybe I only care about this URL, which has more information about this earthquake. Maybe I only care about that type column and the latitude, longitude, and the point column. So one of the things that you can do very easily is things like manipulating the data, removing columns from a data. If I pull in this modify table column functional, I can do something like remove columns, or I can extract columns. And so I'm going to extract a few columns from here, meaning I'm going to specify the columns in that functional output that I want to keep. So I only want to keep the magnitude, the time, the type, maybe the longitude and the latitude, maybe the point object, and I think I said the URL earlier, so let's just throw that in there. Okay, so we specified those columns, and now if I were to rerun this whole workflow, let's even change the area. Hopefully there'll be some queries up here. If not, we can run it again. I'm not sure if there's queries up here or not. I'm gonna hope there are. So we run this. If I view this, actually, there's none. Okay, so let's query a different area. Let's just go back to where we were. Okay, so starting from scratch, I'm gonna run this workflow and I'll clean this up while we're running it. And so this is starting from scratch. It's running all of those different queries again based on the new inputs that we provided. And it's going to do that same process. So this is what we're talking about when we have a repeatable process. Now you as an end user, you can come into this workflow every day. You could change the inputs, you can hit run, and it's going to run that workflow for you. All of those manual steps that you used to do manually, right? You would do that in Excel or you would use another tool to do this. You don't have to do that anymore. It's all encapsulated into this workflow. The other neat thing is that now that this workflow is completed, and I've got my new output with just the point object. One of the things that I failed to throw in there was that name column that we joined that in. So that's probably a useful thing that we want to keep, right? So I'll throw that in there. And I can actually just run this from here. So I can run one step in this workflow if I want by pressing this button. And that will give me that name back. So I threw that name column back in there. Now that we've done this, I'm going to save it. And we'll call this Corey Blast workflow. And now that I've saved it, I can do things like set up a scheduled job. So we have this automation button down here where you can create what we call automation tasks. These automation tasks allow you to set things up to run on a specified interval. So for example, if you wanted to run this every day, and I'll just call this workflow task, I'm going to save this, and now it's going to run every day at midnight. And you can turn this on and off. You can see when the next update happens. At this point, since I didn't specify the output to go anywhere, this would just run. It would create the file, but I wouldn't ever really receive it unless I went back into brewlytics to get the data. One of the things that you can actually do is you can throw in something like a send email functional. And this is really valuable if you're setting things up to run into a schedule, because now I can say, I want to create this table. I want to create a KML file, a Google Earth file, or maybe a shape file just to show something different. I want to create an Esri shape file, and I want to hook that shape file up as an attachment to my email. I want to send this to me every day. And I'm going to give it a subject, daily Corey Blast. And, if we wanted to put things like a body of text in here, we could do that. I'm going to leave that blank for now. And now we've just created a workflow that's going to run this whole thing every day, create the shapefile, and then send that to me through email. So this was a fire hose of information, but what it was designed to show you is kind of a quick and dirty introduction to brewlytics, so you understand conceptually what it can do, what it's capable of, and how to build one of these workflows. As I said at the beginning of the video, we're going to have a lot more targeted videos for certain features. And so if you're interested in how to create a more, let's say a more advanced workflow with things like iterators, which is basically how you do a loop within one of these workflows, you can put in conditional logic. So you can say, if this table is empty, then I want you to go do this. If it's not empty, then I want you to go do this. So these workflows can get very elaborate and very complex. And that's really the power of the tool. You, without coming in here and writing any code, you can build one of these workflows. Now, if you do know how to write code, and let's say you're a Python expert or an R expert, or you dabble in SQL, you can throw these functionals in here where you can write your own code. So we've got a little bit of something for everybody. If you want to do some machine learning or something like that, you can write the Python code in here. We have all the Anaconda libraries. We can add other libraries in here as well. So there's a lot of capability for you to do your data analysis regardless of the type of analyst you are. Thanks for tuning in.